Hi everyone. I go by Nelson, data scientist, nano degree program mentor at Udacity, and predictive analytics for business mentor as well. So this presentation is based on a data lake value proposition meant for the medical data processing corporate, and I'm going to directly get right into the core. Give me a moment, please. Thank you. Let me enlarge my screen for the presentation to be visible. There we go. So the agenda of the presentation is based on what the data lake is, the components of the data lake, the data lake versus the data warehouse, the business value of the data lake solution, and the proposed data lake architecture for the medical data processing system. Diving directly, we do have a data lake being a system or a repository of data stores in its natural format. So usually it takes the form of blobs or files with three main purposes. The very first is to character all kind of data, store the data in its raw format, and character it to a spectrum of users to enable faster insights. The second is to enable data cataloging and governance in an agile manner. And the third but not the least is to offer an end-to-end solution for a cloud suitable implementation in an economical and scalable way. Of course, a lot of corporate and business architectures are being designed so much so that it takes a SaaS format, right? A system as a service, software as a service, excuse me. So moving to the next slide, we have the data lake segmented into four main layers. The first layer is the ingestion layer, which takes in data in either a structured and or unstructured format. Of course, sometimes we could have semi-structured data holding some metadata, but for this architecture, we do take in data in either a structured and unstructured format. Now, based on the medical data processing corporate, data is ingested from three main sectors or sites, or let's say data sources. The very first is the FTP file servers, the second is the file exchange agents, and the third is API agents. API agents could be a set of public APIs, for instance, published so much so that it is a convention through which you can access the data in one way or the other based on the signature of the API. API stands for Application Programming Interface, of course. The second layer is the storage layer. Now this layer contains two main data stores. The first is the raw data store and the second is the processed data store. The third is the processing layer, which contains two sub-layers. The first is the batch processing engine and the second is the real-time processing engine. Now we have the fourth but not the least layer, which is the serving layer. Now the serving layer contains analytical sandboxes, much more used by data analysts or data engineers or even data scientists to have a deep dive into the raw data sources and see what kind of insights they can come up with for informed decision making. The second sublayer in this layer is the presentation layer, which is much more for high level stakeholders. Of course, we're going to go into each of these layers in the architecture in an in-depth manner. In the next slide, we have the data lake versus the data warehouse. Of course, this medical data processing corporate do use the data warehouse, which is bringing them a lot of problems. So having a deep dive into what the data warehouse is it is being used by most data architectures for an established period of time and has shown its limitations, of course, against the data lake architecture in three main aspects. The very first is on scalability. The second is on the support for structured, unstructured, and semi-structured data. If you remember in the previous slide, our data lake architecture spoke of getting data in either an unstructured or structured way. This solutionizes this second limitation of the data warehouse. Now, the third is the independence from a fixed schema. And these aspects are later on compared as thus. So, having the data warehouse in the traditional architecture, we first have to understand the data, model it, and then load it. Whereas in the new data lake architecture, we load data first in its raw format and then decide later on what we should do with it based on the audience and based on the kind of users for that data. The second is the data in the data warehouse is stored in a structured form, whereas in the data lake architecture, the data is stored in its raw form, hence its distilled water-like property. So the distilled water-like property here speaks like the ability of a lake to be used for many purposes. For instance, if you go into a lake, you have the shore where some people could be fishing, you have the inner part where other people could be kayaking, others could even be having some touristic moments, others could be playing with kids. So the lake is malleable and can be structured in many ways, so much so that it attends to a specific user's need. That is just what the data lake architecture speaks to, and that is what it has as ability in its processing powers. As third comparison, we do have the data warehouse, which is of course a fixed schema and with its limitation set and structure defined before implementation. This brings a lot of hurdles when the company is scaling up from time to time. On the other hand, the data lake is an agile architecture by nature, and as data is stored through cataloging, and so you can scale with time as your corporate improves. The fourth but not the least is the fact that the data warehouse supports a defined set of users described before implementation. So if you have a new set of user that comes in and the data lake wasn't meant for them, then there will be need to completely modify or completely change the data warehouse to a new one. Whereas the data lake architecture can of course be modified for all kind of users in a kind of agile process. Moving to the next slide, we're going to look at the business value of the data lake. Now, give me a moment, please. The medical data processing company has experienced a hyper growth over the past 3 years. And however, as the volume of data continues to grow, the existing infrastructure of the corporate has not been able to scale even at its optimal capacity. So, building a data lake for the company will solution current problems faced by the current architecture, as the following business outcomes will be achieved. So, four main business outcomes are achieved when this medical data processing corporate decides to adopt a data lake architecture other than the data warehouse which they currently host, with the variety of problems that follows it. The very first business outcome achieved is the ability to load data in its raw format at scale. The second is the ability to support all types of user in the company. The third is to create an agile environment by nature. And the fourth is to enable separation of compute resources. Now, by separation of compute resources, we mean having work not necessarily done by the data lake architecture, but already ingested from maybe a third party without necessarily keeping it into a data store. That is the use of the real time data processing engine. For instance, if we take social media, you might want to know analytics prior tweets, right, or Twitter, but you don't necessarily need to store all the data from Twitter before carrying out those analytics. Of course, Twitter provides you a form of API so much so that you can access and also come up with some analytics prior to a given hashtag, for instance. So that is a form of enabling separation of compute resources and just getting results from a specific compute resource in order to complete some form of analytics that will be useful for the corporate. Speaking of which, here is the data lake architecture. So now, as you can see at the extreme left, let me use my mouse to hover around that. We see the medical facility points. It could be differentiated by geo, it could be differentiated by location, it could be differentiated just by function also. Of course, these various medical data facilities could start with one store and scale with time to 10 and even 100 plus stores, as many as you want. And the main data ingestion layer here consists of the three main layers which we spoke about. Either data could be from an API agent, it could be from a file exchange agent, or a file server. Now this data is either structured or unstructured. So each of these data, which is either structured or structured, passes through extract load processes, and the extract load processes make sure that this data is stored directly in its raw data store. So when this data is stored in the raw data store, there is no processing that is taking place. This keeps and saves huge processing power and time for the complete system in order to use that much more fruitfully or much more economically for other processes that needs the compute time. So that said, in the data store layers, we do have the raw data store and the process data store. So in between the raw data store and the process data store, we do have the processing engines. Now the batch processing engine, of course, does nightly works, for instance, or does the work when there is no major activity in the corporate, in terms of taking useful information from the data stores, giving it a schema, giving it a shape, giving it a structure, and processing it so much so that it can be later used by the presentation layer. Unlike the batch processing engine, the real-time engine takes in data directly from the ingestion layer. This could be from real-time data feeds, right? For instance, social media feeds. For instance, getting the pulse of or a sentiment of a particular trending hashtag or a particular trending news. And to get that pulse, of course, time is a major factor, and we won't want to process it and I mean to store it in its raw format and process it later, else it won't have its value compared to when it was done in the real time manner. So that said, when all of this processing are either done in real time or in batch, of course they are stored in the process data store. And later on, this process data store can provide us insights to a presentation layer, either in the form of a data visualization dashboard, a report, or some form of analytics. And speaking to this form of presentation layer, we have another form of presentation layer which we shouldn't forget, right? The analytical sandboxes. Now, the analytical sandboxes do have three main components. We have first the data discovery, second, we have the exploratory data analysis, and third, we have the modeling components of things. Now, the main users of this sub layer are we either have data analysts, we do have data engineers, or even data scientists. They take in data directly into the raw from the raw data store and try or attempt to come up with insights or statistical measures for stakeholders to make insightful decisions or informed decisions. So speaking to this data lake architecture, we see it adheres to all the principles of an agile company. It adheres to cataloging. It adheres to the fact that you can start small and scale right up to a big entity, and depending independent of the number of users or the type of users, because due to cataloging you can have a specific solution to a specific set of people. For instance, for the business function of the corporate, for the financial function of the corporate, for the marketing function of the corporate, for the inventory function of the corporate, for the medical facility in terms of the medical data lake architecture, for the medical data processing corporate, for instance, for portraying medical facilities in real time without necessarily having to process the data each and every time and storing it directly into a raw data store, unlike the data warehouse. That said, this also helps into enhancing the various application layer issues which are generally caused by load balancing. You will realize the bandwidth is now easily manageable and malleable because there is more processing power. And the really interesting thing about the data lake architecture is the fact that it really adheres to the Moore's law. The Moore's law speaks to the fact that with time we have an increase in need for processing speed, and again with time we have an increase in need for data storage, and the data lake architecture is made in such a way that it adheres to the increasing needs of the processing speed need of the processing power for a corporate, or the increasing need of the storage needs of the corporate. So that said, this is the data lake architecture, and it speaks to the business functions of the corporate, and it speaks also to the business problem. And sure, I definitely look forward to this implementation, and also as to answering respective questions related to this architecture. Thank you, and you look forward to the next one. Bye bye.